So here we are with example 2. A particle P has velocity of minus 3I plus j at time t equals 0. The particle moves with constant acceleration. So immediately we're thinking Ch8. Constant acceleration. And we're told the acceleration is 2I plus 3j. Find the speed of the particle and the bearing on which it is travelling when t equals 3. Okay, so let's list out, well, first of all, we need to go constant acceleration. That's what we've picked up on from the question. As it's Ch8, we can start going through and listing things. So u is equal to minus 3, 1. Again, I'm going for the column vectors. That's the initial velocity because that was at t equals 0. We're told a is constant and it's 2, 3. Find the speed of the particle when it's travelling at t is equal to 3. And we want the speed at that time. Well, before we can get to the speed, we've got to work out the velocity. Yeah? So we need v so we can find speed later. Okay, so all we've got to do now is think, what equation do we know which contains v, u, a and t? Well, hopefully you remember that from when we were doing the projectiles. So we know v is equal to u plus a t. Now, I've put squiggles under the v, u, a, but not under the t. Any idea why that is? Well, these three, the squiggled ones, are vectors. They have magnitude and direction, and time is a scalar. So it doesn't get a squiggle, right, because it's not a vector. Okay, same was used over on this side over here. Yeah, v, u and a have squiggles, t is a scalar. Try to be disciplined about it. Okay, so now we can substitute in. So we get v is equal to u minus 3, 1 plus a, which is 2, 3, t is 3. So work it out. 2 times 3 is 6. Take away 3 is 3. 3 times 3 is 9, plus the 1 is 10. So the speed is the magnitude of velocity. Yeah, the speed is magnitude of the velocity. Speed is magnitude of the velocity. So use Pythagoras. Oops, I don't know what's happened there. Use Pythagoras. So we get 3 squared plus 10 squared square rooted, square root of 9 plus 100, square root of 109 is going to be roughly, well, it's going to be between 10 and 11, probably about nearer 10. Take 10.3, 10.4. You can check it on a calculator. 10.4 meters per second. Okay, so we think we're finished. Go back, read the question. Find the speed, we've done that. And the bearing on which it is travelling at t equals 3 seconds. So we've got to find the bearing. Well, to know the bearing, we've got to have remembered how they defined things at the start. So of this section. So that was I and J, and that's north and that's east. Right, and that came at the beginning of the previous example of how they were defining things in this section. So, if we're going to do this, we want to draw a quick sketch. And we're going to start somewhere. We've got to go 3 across and 10 up. Okay, and now we can choose to find the angle, the bearing with the north line. So that's the angle we've got to find. That's the same as that one because they are alternate, because these two lines are both vertical, or north lines would perhaps be a better way of describing them. So they're parallel. So we know that we can now find theta, because we've got the opposite and the adjacent to a right angle triangle. So tan theta is equal to the opposite, which is 3, over the adjacent, which is 10. So this is the opposite, adjacent. Tan theta is the opposite over the adjacent. Okay, so to find the angle, theta equals arc tan of 3/10. And again, you're going to tap that in a calculator. It's going to be something between 15 and 20 degrees. Tap it in. What does it come out to be? 16.7 degrees. So if we're going to give it as a standard bearing, what do we know about bearings? Got to remember that GCSE knowledge. 3 figures, clockwise from north. So here the bearing is at angle 16.7 degrees, so the bearing is 17 to the nearest degrees, clockwise from north, but it's got to be 3 figures, so it's 017 degrees will be the bearing. And that's the end of that example. I think we can go back, check, nothing else lurking in there, find the speed of the particle and the bearing on which it is travelling at time t equals 3 seconds. No, nothing else there. We've got the bearing and we've got the velocity.